Okay, so hello everybody. Today we're going to speak about the traces. I will try to introduce you to this facility that Db2 provides. It will not be any marketing or anything, so it should be really technical. And let's get started. So the agenda is we will speak a little bit about the tracing as it is, just overall introduction. Then we will focus on the specific traces, so I will try to present you what you might expect from the Db2 traces. So we'll speak about the subsystem monitoring, we'll speak about the accounting data, about SQL tuning with the performance, and then I try to came up with some real life examples, so some sample investigation scenario. And then we will cover what is new in Db2 11. So anytime if you have some question or anything, please stop me and ask the question. Okay, traces. As of Wikipedia, traces is just a set of steps that program executes, and this is what the system can tell you what is happening inside. So, and within Db2, tracing is provided with the instrumentation facility. Probably you heard, when the vendor says about instrumentation, that's basically traces. Trace records and reports what is happening in the Db2 about the Db2 events. And each event has specific ID. So we call it IFCID, or somebody says IFCID. And there are, of course, since Db2 is a complicated system, there are a lot of different events. That's why there are a lot of traces. I think altogether there are around 350 different types. And if you want to get really detailed information about that, go to your Db2 library, find that library SDSN VIPD, and find this member. There would you find all the descriptions. Of course, you may also look in the manuals. I personally prefer go directly on the mainframe. And important thing to understand that capturing and analysis of the traces is happening outside of Db2. This is not something that happens inside Db2. Just Db2 gives you the traces and some tools, or you process that. Okay. And this is simple overview. So imagine you have a Db2 here. You have some user programs that are connected to Db2. And as they do something, you will get a record. You will get a trace record that goes to some destination, usually some file or some buffers. And you have this component, which is instrumentation facility component. And two things to remember from this slide. There are two types of traces that you may get. Either when something happens asynchronously, it means some event happened. For example, deadlock, you get a record. Deadlock, you get a record. Or it could be interval-based. So just status of the system, every minute you get information and you have it in the destination. And a destination, then you may have some monitoring tool. I believe that everybody right now has some kind of monitoring tool. And that monitoring tool get the data and build the reports for you. Very simple. So, and everything starts with the start trace command. So if you don't start the trace, you don't get traces. So any monitoring tool basically on the cover just really starts the traces. So, and the trace command tells to Db2 what to capture and where to write it out. So there are two processes, capture and write out. And there is a sample command. It's the whole syntax you can find in the manual, in the Db2 Commons guide. So basically start trace, then you say what kind of trace you want. It could be performance, accounting, statistics, audit, monitor, and then destination. Most common ones probably go to SMF. I think everybody's familiar with SMFs, right? Or it may go to GTF, which is generalized tracing facility. Usually where you have a lot of traces, you don't want to put it into the SMF file, otherwise it will be full too quickly. Or monitoring tools, they use the buffers. So they just write to buffers where it's been read later on. Then you say what is the class. Class is just a group of traces, so we'll cover to that. This presentation is basically very based on the classes, because I don't believe that anybody is really interested in specific IFCID. More people are interested in the classes. And there are some restrictions. If you want just some specific plan or specific authID, not everything. Out of the box, Db2 starts by default the accounting and the stats traces. This is the classes 1, 3, 4, 5, 6. and for counting just class 1. And as any command in DB2, you always can display the status, or you can modify, or you can even stop that. And now let's speak about the base classes. So statistics, very common class. This basically serves and tell you what is happening in DB2 as a whole. Really take it as a big level, just what is happening in DB2 as a subsystem. While accounting gives similar information, but it gives you on the transaction or thread level details. Then performance, this is basically if you want really investigate some performance problem or something, that gives you normally very detailed information. So these two things you might want to run on the regular basis, while performance, if something really weird happening and you want to look deeper. Audit is also very interesting traces. Is something if you have some audit tables or anything, you need to capture the audit traces. And the monitor is very close to what is accounting. Is basically used by the monitoring tools. And then have a global. Global, I don't have an idea what it is. It's basically for IBM. I never use that. Okay. Now the components. So IFCID or IFCID, and it represents the statistical or information in about the DB2 or some event. Okay. So for example, accumulating system services, you get a IFCID 1. Thread termination event, when some thread completed, you got a record 3. Or if you have SQL completed, you got a 58. So just some trace records. Important thing, many people miss that IFCID serves two purposes. One is to turn on the data capturing within DB2. It means just, if you have locking trace events, just every lock is traced. That could be a lot. And the second purpose is to externalize. So you may capture a lot of information, but you may write down just 3 records. That's important to understand. And there is a separate overhead related to each of these purposes. So you should, for example, on the previous command, when you have the command, you might say, I just want to see the traces for specific authID. You would still pay this price for capturing that, but just less records will be written out. And another thing about the classes, so there are classes within each of the trace types, and they usually serve some specific purpose, so just a set of IFCIDs under one class. Okay. And that's overall about the introduction. Anything make sense? Still with me? Okay, good. So now we will speak about the specific traces. Yeah, here on the top, this is, in red, this means the topic we cover. And let's start with the statistics. So statistics are very common to run the class 1. Class 1 give you overall view on the DB2 subsystem. Important that overhead is negligible. It's really cheap to run, and we really recommend you to run. Even there are 9 classes altogether in the statistics class. Just run all of them. That would be good for you. You will, whenever you need it, it just costs you nothing. And there are just few records being cut every minute, so it's not a big. Normally, our records are externalized on the interval basis, and very common they just stored in the SMF. So as I said, out of the box you have the default, by default started some of them. And what could be interesting, this is right there, the specific records. So for example, record 1, that give you the information about the DB2 other spaces, about the commands, how many commands altogether for the last, 10 minutes or last 1 minute. It's actually accumulated, but most of the monitoring tools do the deltas. So you would see for the last minute, or you may do for the last 10 minutes. It also gives you information about the storage manager, lock manager, latch manager, just how the subsystem behaves. And the database statistics, record 2, so it could be, for example, stats on SQL, how many selects altogether the system process, or buffer pool stats, or group buffer pool stats, or EDM pool, logs. And if somebody has the DB2 accelerator, that would be also in record 2. Zip arms I don't know if everybody is aware, sorry, that Db2 gives you the record with all z params every minute. So if you want to, you can go back to the trace and see what were the records at that time. Buffer pool parameters, record 202, so you would see what are the parameters that you define for the buffer pools. And 225, Db2 storage utilization, how much space altogether, other space each. With Db210 is a bit less important as it was in Db2.9 when the visual storage was the problem always. And the question is, why would it be useful? So it's basically, as to the statistics, is really get a statistical view on your subsystem resources. CPU time, how much CPU each other space consumed, what are the different commands and sequels were executed, records 1 and 2, number of get pages, updates, read IOs, etc. in the buffer pool. So you may really see your buffer pool stats, or then accelerator. Here I just put some screenshots. Those are from CA Inside, since I just don't have any other tools, so use that one. So, but basically, this just may give you an idea what you can get from here. That continues, and EDM pool size utilization. So you want to know how your, for example, dynamic statement cache is being used. Or you may get a system parameters or the memory. There could be a good idea to keep these records for a longer time. So most of the tooling allows you to get the data from SMF or just from history files and offload it into the Db2 tables and keep it, I don't know, for years. So if you then want to do analysis, if your subsystem at some point starts, growing in the CPU utilization, you may look back, 1 month, 2 months ago and just compare if it is okay or not. Basically, any analysis starts with taking the history data and just start comparing. Class 3. Class 3, this is already the event-based IFCIDs. So as something happens, you get a record. So it actually captures information about the contentions, coupling facility, buffer pool stats, lock escalations, long running, unit of recoveries. And again, all the subsystem statistics is overhead is negligible. Just really run that. In this case, the stats, if you run it to SMF, they go to different one, to 102. Db2 uses just 3 SMF types, 100, 101, 102. So the first class goes to 100, accounting to 101, and the rest of them goes to 102. So just 3 SMFs, but all IFCIDs, put into there. Interesting IFCIDs, deadlock 172, timeout 196, dataset extension 259 or 58, then long running uncommitted unit of recovery 313 and 337 lock escalation. So if you have this class started, that's what you will get. And why it is useful, basically that allows you to know when some system event, what are the system event and how Db2 how Db2 process that event. So the good samples would be the deadlock or timeout resolved, and you might see what were the tasks, that were in the deadlock or timeout. So in this case, there was a task holding the lock, and there was some victim that was waiting for that lock, waiting, the threshold, and then it was kicked off. Or for example, this case, you get a lock escalation. There were way too many locks, and the page lock was escalated to the table level. What else we can get with the class 3? If you get some data sets, this is basically where you have your tables. If they get growing, they get extended, then you get a record to 58. So if you want to monitor some specific, it's basically for every data set, but if you want to really know your fast-growing data set, then you might want to run the class 3 and you will get it. And the transactions that didn't commit for quite a while for this Z param that tells if there are this number of checkpoints and there was no commit, you will get a notification about that. So some samples is that. Okay, still with me? Yeah, class 3 or 4, 5, 6, we will not go too deep detail. So class 4, about the exceptional conditions from the DB2 perspective, what DB2 says is exceptional. Class 5, data sharing global stats. Class 6 it basically has one record, which is already part of the class 1. So again, overhead, it doesn't matter. And some of them are externalized on the event-based, some of them just, every minute. Interesting IFCIDs, 402, DB2 profiles. I just wonder, does anybody here use DB2 profiles? Okay. Then 230, this is very similar to group buffer pool parameters, just group buffer pools, and the storage. So why to use that? Class 4, if you want to know when the specific threshold reached. So you may use the resource limiting facility, then you will get some notifications, or use DB2 profiles or some other thresholds. Then you will get a record. So in this sample, I just defined a class, some profile, and tells me when the number of connects more than 1. Just I get a notification. Class 5, if you want to know your group buffer pool parameters. So if you change that or anything like that, you can find it. So if you run that, you will have it. And that's pretty much it about the subsystem monitoring. Now transaction. Honestly, it took me a while to understand how these things work together. And I think there is a lot of misunderstanding here. So accounting is useful when you want to look at your particular transaction or connection, as you may think of. And there are only 2 IFCIDs. One is 3, which is plan level accounting record, so information on the plan level, or 239, which is on the package level. So, and there are only 2 of them. While we always speak about the accounting classes, basically you still get the same record, but with different types of details. I mean, if you run class around 1, you get a just limited set of details. If you run more classes, you will get more details in the same record. So don't get confused. And if you look again in the documentation, you would say, okay, you started class 3, then all bunch of IFCIDs started, but they really started to capture the data. But externalization will go to these 2 IFCIDs. Okay. And records is normally produced when the thread is terminated or is reused. And normally or often just capture that to the SMF 101. So now about the classes. Again, plan level details. So class 1 is just overall application laps and CPU times. If you're familiar with ZOS, it's basically TCB times. Very simple to capture, very, very cheap. Then class 2, this already times as the thread spans within DB2. It means DB2 lapse time and the DB2 CPU times. Class 3 covers a bunch of different wait times. So if you spend time in I/O, in locking, so this is the level of details you will get. Then 239, if you want to get this record, you need to start these 2 classes. 7, it will be elapsed and CPU times, while class 8 will bring you the wait times, or suspension times, as they call it. So overhead may differ. I mean, that's pretty clear. I mean, if you have a lot of threads, then overhead will probably be a bit higher. If you have just a few threads, that's, should be lower. And again, if you turn on all 3 or all classes, then it's probably just a little bit higher overhead. But I really recommend to run all of them. Yeah, and this is my favorite slide. I'm getting confused, when I was initially learning that section, I saw, all these complicated diagrams, try to understand what is what. I tried to make mine. So just envision how it happens in DB2. I mean, obviously this time, so just, I came up from top of my head. So imagine this is accounting class 1 times, class 2 times, and wait times. There are more events here. I just put one of them just as a whole together. So imagine that at moment 0, program connects to DB2. And then this is where application elapsed time started for that application. You basically may imagine that you have a stopwatch, you turn it on, and it will running till the end. And then it stops. This is what you get in IFCID 3 in the end, as soon as thread terminated. This is just you get really few counters. That's all you get. But this is how those counters, how the time is being calculated. So for example, the second step, DB2 allocates a thread. Since it is something happening in DB2, right, You got a CPU time here, you got something time in Db2 labs, and you got time in CPU. So something happening. So you have 4 counters running, 4 watches calculating the time. Then program waits for some command. Nothing happens on Db2 side, but the elapsed time is still running for that application. Then prepares some SQL, then something again with application, then Db2 receives that. You got a elapsed time, then start processing, so you got some CPU. And then you need to do some I/O. At that point, you got a new counter, new timer that will count the time for I/O because there would be no CPU just really waiting as channel subsystem will let you know about that. And it's pretty simple like that. So as you see in the end, you will get just some times. So you would say, okay, for example, a very simple case, batch job was running 80 seconds. Out of 80 seconds, 50 was the CPU. And out of those 50 CPU seconds, 45 was spent in Db2. And, out of that, elapsed time 45 was in Db2, and 25 out of 50 was actually what Db2 was doing. And just 10 seconds it was waiting. For subsystem. And there is some time there is not accounted. Also very important to know that something happened outside of Db2 and my application just was waiting for something that I don't know what exactly. Any questions? Make sense? Yes?
So if you have a thread coming into the dist task from a remote server, would that count as, and it's waiting inside?
Yeah, if you have a DDF, I think you will have only these times. Because you don't have the application at that time because it's everything in Db2 in a way. Okay, and looking at those metrics, couple scenarios. So let's run those classes. 1, 2, 3, plan level, 7, 8 if you want a package level. Then if you want to understand what are the applications running, because each thread will tell you some details about that transaction, like a correlation name, which is job name, or it could be auth ID, so that you can identify your application. And then looking at those metrics, saying, if you have, for example, big elapsed time, but low Db2 elapsed time, maybe it's some networking problems that you were, application tried to do something, but it was not in Db2, so it was something within your program. Or it could be, for example, you have a really big CPU time for application, but low in Db2, maybe your application is not that, good written, or maybe it's normal. Maybe just no problem like here. Or for example, if you get a, big elapsed time and just very little CPU time, then you might look into the wait times. Maybe, you were waiting, you had some blocking problems or IO problems, something like that. Or it could be just completely normal situation. It's just really, you need to know a little bit about your applications. Or what our analysis will go further, just compare what was in the history of what happened just yesterday, for example. And just some sample reports again. You may see all the times here if you want to. Also from the accounting trace, you may figure out what are the statements types, statement types, not the exact statements, but what are the, for example, selects or inserts, and how many times were executed for that transaction. Then how many suspense and what kind of suspense there were there, and the number of commits, rollbacks. Then you may get a buffer pool related information that job used, had so many get pages from the buffer pool request. Then you also get the zip, Db2 analytics, accelerated execution, or eligibility time. So you may get if you run the Axel models, accelerator modeling, then you will get some metrics here also for accelerator. Okay. Next topic, SQL tuning. Performance classes, there are 23 classes. So for different types of events, definitely will not cover everything. I will just really take one class. So what kind of events could be? For example, SQL activity. So there is a special class that groups the related records for the SQL activity. Or for locking, if you want to really investigate into the locking, then you start another class. So you really need to start it and get it. Then sorting, claims, drains, datasets, open and closure activity. Then details on the binds, command utilities. You see, there are pretty, everything that you want to know. But again, you should use that carefully when we really need to. Because for some cases, like, I don't know, locking, again, it's the worst example probably. If you want to see every lock, you can imagine how much data it may generate and what could be the overhead, right, for every lock. Or IOs. I didn't put it here. So if you want to see every IO, so, that would be a lot of data. So that's why the overhead may be considerable, up to 100% for these kind of events, or generally, for example, you capture the SQL activity, it's not that bad. And we will speak about the class 3. Class 3 is for SQL activities. You may see SQL starts. For different types of the SQL, you get a different record. So for insert is one record, for delete another one. Then you get one record for SQL end. So if you get a start, end, you do the difference between them. You figure out how much CPU was spent for that SQL. This is what monitoring tools are doing, because normally from the trace, you will not be able to do that. Then SQL text. So you might really get a SQL text. You may get the package or plan allocation details. And there is also a record for store procedure, start, and end. So why it could be useful if you really want to know your SQL. So if you want to tune some application with the SQL, so you start that and see the flow of the SQLs with the text. You see the metrics, how much CPU a particular SQL consumes, and understand what are the SQLs that belong to your application. So running that, I don't truly believe that you probably want to do that in batch. I mean, you usually, go to your monitoring tool and start it online and just check it. But still, I mean, if you want to, you can go and analyze that in batch. I just don't like it, going through so many pages. So. You can also identify, if you have something like that, you may figure out what was the SQL with the worst elapsed time or response time. You can find out what are the most expensive statements. Or if some particular statement would have a big I/O or log times, maybe there is some I/O wait problems. And many more. I mean, that can give you a lot of detail. So performance traces may be very useful to these kind of specific situations. And I also added the monitor class, which is very close to accounting. So it also has, I think, 9 base classes, wherever here we're counting 1, 2, 3, 7, 8, so very close to that. But default destinations buffers. So what happens, Db2 writes trace data in the buffer, and then monitoring tool goes there and take it from there and do the processing as it needs. The data could be accessed either asynchronously, it means something happened, get a record, something happened, or you may ask Db2 saying, using the read-as, which is synchronous request, you say, tell me what is your list of active threads. That's going to be, give you this, that would be synchronous request because you ask and you wait for the reply. Just how it works, some details in the background. And there is one interesting class 29. So there are 2 interesting if kits, and this is why I wanted to put it here, 316 and 401. 316 basically tells you when some specific statement is evicted from the dynamic cache. Just kicked off, and you got the record. In real time, if you have a monitor, you can go and see what is in the dynamic cache with the statistics. Or 401, this is similar to 316, but it's for static SQLs. So why it could be useful? I call it cheaply identify expensive static and dynamic. So if you have query monitors, you gather details for each and every execution of the statement. While with this class, you gather aggregated metrics. So you get some specific statement, and you see the elapsed time is accumulated. I mean, if you had here I have 26 executions, so it's all together for that. But if you don't have any query monitoring tool, that may be the place where you want to look and browse your SQLs. Of course, there are some problems. So for dynamic statements, you got just 60 characters. If you want to get the whole text, you need to get another record that is only available through the synchronous request. So it means through the tooling. Or you can open a request to IBM and ask to get this record, every time the statement is kicked off from the cache. So we opened that, so far no reply. So, but still, I think the community would benefit from having that record.
Yeah, you should put the RFE number here.
Okay, I will. All right. I think you have some site, right, where you vote for that, so yeah. I was putting my vote. Okay. And that's it about the top useful phrases. Yes?
There was a slide about writing to OPX. The one slide before this.
Sorry?
The output, when you write to an output buffer, we sometimes have problems that the output buffer fills up. Is that size of that buffer, is that
correct? Yeah. So
from
the
Db2 or from the tool?
This is the question is, sometimes the OP buffer is being filled. Yeah, this is what you define in Db2, saying this is the size of the buffer. So if your monitoring tool is not quick enough to clean it, then you lose the data.
But can you make the buffer
bigger? Yeah, you should be able to do.
Start trace. You can, I think, up to 64.
On the start trace, you can specify the size of the buffer.
Okay. I don't remember myself, so maybe that's the right answer. But we can look at that, later on. So, but definitely you can change the size. And important thing that you start the monitoring tool on the same or higher priority, dispatching priority than Db2. Because otherwise Db2 will be writing too many records that monitoring tool will not be able, to get dispatched to take it out. So that's why it's important to have it on around IRLM priority. Around time? That's good. I'm pretty quick. I'm surprised. So now meet the reality. Imagine the simple use case. So let's say you have a batch job, which is called payroll, and somebody tells you that job ran yesterday twice longer than before. So how you would, start with here? There is some analysis scenario. You probably need to look at if it's really your problem or not. Then maybe there is some access path changes, or maybe some blocking problems, or maybe there was some I/O problems, or just something weird happens on the subsystem. So I made that scenario purely based on the counting data. So imagine that you have just accounting records, okay? Just for the sake of making it simple. So first of all, what you need to take, as I said, you want to keep the history. So you look at your latest execution of this job and the previous one. So you would have two trace records that you want to compare. So the first question, if it is your problem, so you, knowing the job name, the correlation ID, you will find the historical elapsed and CPU times. And if you compare them with the previous execution that is the same, so now it's not your problem. Db2 elapsed time, CPU time, same, sorry. Problem somewhere else. You go to application developers and, beat them. Or if there is a big difference, then obviously you need to investigate further. Access path changes. If you run 239 record, classes 7, 8, then you will know the packages that transaction touched. So you may go to the catalog and see maybe there was some, the packages were rebound. And then you look at the bind times and just check, go to the explain and compare, explain the output and just check if something really changed. Of course, that will work well with the static SQLs. With dynamic, it's probably much worse. I was thinking carefully what could let me know that access path for the dynamic statement change. It is really not easy to identify those. So, but could be maybe you may look at the number of get pages for your transaction. So if get pages grew dramatically, that means you processed much more data than probably access path changed. You may look at the parallelism. So if parallelism dropped, then obviously the transaction will take longer to complete. Or you may look at the prefetch and sequential prefetches. Maybe there is some big changes there. Or you may even look at the lock and unlock numbers. So here you may see how many locks it was asking. So maybe it was repeatedly trying to get some lock and was not able to. So it may tell you that something changed in the way the data are being accessed. And probably if somebody has a better idea how to identify, I'm more than welcome to speak about that. Locking, you would probably go to your wait times, and there is special lock wait time. There are multiple metrics in that, but you will figure out. So altogether, if you would see the locking time, which you need to capture in class 3, so if you would see that locking time is big in comparison with your previous execution, then obviously you need to investigate what could be the reason for that. So maybe you might want to look into the your statistic class 3 data, see maybe there was a lot of deadlocks or there were a lot of timeouts that somebody was taking the resource, or maybe you just compare how many there was lock suspense, so that you're waiting a lot of times. Unfortunately, in the trace data, you cannot figure out what was the resource you tried to get. So that's unfortunate. I mean, with some tools you can get it, but out of the box you don't get it. Maybe there was some waits for I/O operations. Pretty much the same screen. You go to altogether, see if the wait time was big, then you were waiting for some I/O. Again, what I'm here speaking, you basically compare two executions, because on its own figure out, I mean, if it is good or bad, this is just a separate problem. You might want to reduce the I/O times, but it's a completely different section. I mean, way to approach that. You just really need to know if it is a lot of short I/Os or it's just few long-running I/Os. But in this case, when you compare, you just really check if the time changed. If the change, then you need to investigate. Maybe there was a lot of read and write I/Os, so maybe you are overusing your buffer pools. Or maybe there was a lot of rollbacks, so there was some problem. Then you were reading the lock all the time. Or maybe there was some read overflows. Then you use the work file. So that also takes some time. And the last but not the least, maybe there were some subsystem problems. So that could be reflected in the higher CPUs or lapse times. So for example, maybe you don't have enough EDM pool space, so then you have a lot of shortages, so the statement wasn't found there, so it was excessive preparing. Or those literal, so it couldn't find anything in the cache again, then it had to prepare that. Or maybe because of the system just thinks that it is too busy and just drop the parallelism, then it will take longer. Or maybe if you have zips on your system, then zip time went down because it was just taken by somebody else. So that would mean many of your zip eligible workload will be routed back to CPs, common processors in a way. Then that will be again reflected in the longer lapse times. So what you can look into here, you want to look into the not accounted time, which is time between you have Db2 lapse time, you subtract the CPU time, you subtract I/O, suspend time, and then you get accounting. Most of the performance tools will do the calculation for you. So that big time can represent the problem. So it could be, for example, you have excessive paging on your system. So some processes require a lot of paging, and that would be just something happens on the system, so you may look into that. Or maybe you don't have a proper VLM goals. So just you don't get a proper dispatching priority. Or maybe you just don't have enough CPs. You have some LPAR with one small processor being shared with another LPAR. So that would obviously be longer. Or one of the reasons could be the tracing. So maybe traces itself, take CPU. That's why you get less for your application. And there are other reasons. So I mean, if you look at that, any analysis really requires a lot of understanding how Db2 works. But those, I try to put some tricks and tips, where you can look at to start your investigation. So obviously there are a lot of, different workshops that may help you, or some certifications or anything. So I would really recommend to go through that and try to understand what might happen. And now we switch to DB211, unless anybody have anything. Okay, what is interesting in DB211? There are just a few new records. One is 377, which monitors the index cleanup daemon activity, and the new record 376, which is reports SQL incompatibilities. And there were quite a few records that were updated. So 58, which is SQL-related record when the SQL ends. Now it has SQL time and expansion reasons, so we'll speak about that query transformation here. Then each of the IFCID got the modified CPU header, which means as soon as record is generated, it really puts there the CPU, current CPU value. So if you get a start and stop records, then again you can do the difference between them and get how much that particular event took, CPU or elapsed time or zip time. So as of DB211, there is a zip time. So you may figure out how much the particular SQL, how much CPU time particular SQL consumed. Then also in DB210, which is after it went GA, there were quite a few new records, 380 and 81 and 497, 99. So that are related to deeper monitoring of store procedures and UDFs. So let's quickly go through that, and then we will have some time for questions, if any. So 377, if as soon as you have an index and some records are being removed from the index, then it does not clean up immediately. So now you have some daemon that runs when you let it to run. There is a catalog table where you put, if you want, for example, run that only during some specific hours or for some specific indexes. So, and there is a parameter that says, how many threads would be doing the cleanup on the moment. So if you put 0, then you will not have it. And this record is generated as soon as each page is cleaned or removed. So you get the details of the index, you get a page number, and you get an indicator if that page is deleted or cleaned. And as you can imagine, since indexes may have a lot of pages, the number of records could be large. So that's not in any particular class. You need to really do the start trace and then specify IFCID and in parentheses the record. That's how you get it. So there are some specific classes, for example, monitor class 30 that has no associated IFCID. So if you start monitor class 30, specify destination, for example, SMF, and put IFCID 377, then you will get it. That's how you do that, if you don't have record in the specific class. Why to capture? It's really over control if you run, if the specific indexes were cleaned or when it run. So probably there is a sample report. It is not for every record, but we really aggregate it for 1 hour intervals. So, but you're going to get these details. 376, this is incompatible SQL or XML when it's executed. So if you're familiar with 366, this record was introduced in 10. So as soon as there is some incompatible SQL being executed, you got this record. But since the same statement can be executed way too many times, in DB211 you get a new record that only generated for a unique statement ID. So you got this record only once for the statement ID. If there would be another one, that you will get another record. So you just limit of number of records that you get. So it's probably in DB211 better looking to 376 rather than 366. So why to capture that? If you want to identify specific programs that are in real time execute some incompatible SQLs. Yeah, I forgot one thing to add here. There is also some small flag in package record 239, the counting record, that tells you if the specific package contains incompatible SQL. So you may get this information a bit quicker or easier. This one is for real time when it executes that. So that flag just may tell you that you have some static function or something like that that is incompatible. So probably you could add it here.
So in that's the Db2 connect example. So it's an incompatible dynamic statement. How are you actually going to recognize where it's coming from?
You will get this one. You will get the auth ID, you will get correlation ID, file name. I mean, for dynamic statements that are coming from
Java.
In Java, yeah, I mean, for Java applications, it's always a problem to identify those. But I didn't put here on the screen, but there are 3 more credentials: the end user, workstation, transaction. Whenever you have your Java application, you may modify those values. So if you have programmers who write those applications, you can really put the values you want to there. And then you will get it in accounting.
The accounting information of the Java thread.
Yeah. So I mean, you want to tell your programmers to put some values there. Otherwise, it will be some mess. I know that it was initially, I guess, introduced for SAP, something like that they start using these fields. But it's now available to any of the programs, so you can just really put it there. But like that, yeah, it's difficult to identify. You just see that this serve plan and yeah, go and find it. 58, again, this is Performance Class 3, as we were speaking about the SQLs, that captures the end of SQL. So there is some start records. So you will have the start records normally paired with the end record. And now in the end record, you also get a SQL time. Before, it was not available. So in order to figure out what was the statement that I got an end record, you need to really look for the start record. Now in Db211, you will know what the SQL type is executed. I mean, you don't need to remember all these keys or anything. I just want to understand what you can expect from the, if you do some reports or some monitoring tool to use, so that you may ask those questions. Also, as Db211 introduced support for special registers or the global variables, then your SQLs may be on the fly get transformed. And you also get an indicator of that SQL was transformed. So if you capture that, if you run the class 3, you will see that statement was transformed. And yeah, this is what we already spoke about, the headers. So many of every record may have that SQL, that CPU header. If you run there is a parameter on the start trace command. So if you start the trace and specify CPU, you will start getting those. This is what the monitor tools are doing. So we start the trace and specify that parameter, so we'll get the CPU header. And right now we get a zip time. So if you do the difference between 2 records, start and stop, you will get how much zip time it spent. In this case, it was 0. So nothing. So why to enable the CPU header? Because you may really figure out, because of the paired records, how much CPU it consumed. For example, you have a number of paired records. Obviously, SQL, we spoke about that, start, stop. Then the scan started, scan stopped, so you can know the CPU, how much altogether it consumed. Sort start, sort stopped. So again, you might get this information. And a few more records, probably of less importance. So 27 was enhanced to report on the sparse index usage. So you have some index on the WAR files, then you may get this information, so how many records were processed. This is in the class 9, so if you want to know about the sort activity, this is class 9. You start, you will get it. Probably a bit more interesting, the records related to the stop procedures and UDFs. You used to have a 233, so just about any invocation of the stop procedure, but Db2 and Db2 10G post-GA changes introduced more changes, saying you may get a nesting information when one SQL procedure invoked another one and another one. So you get this information on the nesting level, so you may really figure out on one nesting level how much CPU was consumed. And you get a statement information. You get statement IDs for particular statements that were invoked during store procedure or UDF execution. So something like that, You got a start, you got the statement. So, you have a statement ID. You may go and extract it from the catalog, or your tool may allow that. So, and those in class 24, unfortunately, class 24 only includes store procedures. So if you start that, I suggest you to add the rest of the IFCIDs, 381, yeah, and I think this one, 499, that captures information about UDF. They're not part of the class, but you can always do the IFCID and then parse SS to IFCIDs, and then you will get it. And with that, I go to the summary. So just please remember that traces, just let you know, is the way to look at the Db2 black box. You can get your hands inside. Use them wisely. The more detailed information you want to get, the usually more overhead is involved. Running statistic classes is always recommended. You may run all of them because overhead is very low. With accounting, I would still also recommend you because you would get a more benefit than you would spend on that. And if there is something really specific, don't forget to look into the performance traces. That will give you all the details you want to. And now time for questions, if any. Yes?
When starting the class, it is possible to remove some IFCID by default, for example?
If you
zip arm?
Okay, the question is if you start specific class, if you can remove IFCID, no.
No, so if you don't want the zip arm, you have it.
Yes,
okay.
If you start the class one, yes. But always there are some classes that has no IFCID,
Yeah.
So you may just start those non-specific classes with the specific IFCID that you want to get.
Okay, thank you.
Anybody else? Any questions? Then there are also some references. Of course, you may look into the IBM documentation. I recommend the managing performance. Very nice manual. You can find a lot of things. Technical overview. There is a new red book for DB211 about the subsystem transaction monitoring and tuning. And of course, as I'm part of the IDAC committee, contact committee, really recommend to go to IDAC website. There are a lot of interesting information, or you may ask questions directly there, so you can find something. And that's it. Thank you. If you have some questions, feel free, to write me emails. If you have some CA tools, feel also free to contact me on the performance tools. I will be always happy to answer any questions. That's it. Thank you.